analysis. These you can be it can be found in this paper in detail. So now, after applying the load, what we found, like the critical observation, like it was not very limited information earlier was there, like how this going to behavior of footing load and slope stability. So this is the stability, like we know factor of safety, and then we increase the loading intensity in terms of intensity KPA. We try to do for the different slope angle like 10 degree, 20 degree, 30 degree, 40 degree. Let's say when you don't have any loading intensity, okay, we don't have any building loads or foundation load, then what you can expect, like if your slope angle is very less, then the bearing capacity, then the factor of safety is going to higher. Okay, so you can see at 10 degree, it's almost 6, above 6, so very high. Then as slope angle increases, then the bearing, factor of stability is going to decrease. So this is somewhat our analysis is expecting as conventional theory says. After that, when we increase, let's say this is for 10 degree, when we are increasing the loading intensity like 25, 50, then there is not much change at 10 degree. If we apply a 10 kilonewton kPa, then there is no change. If you increase a very small intensity of loading, there is no much change, almost constant. Then if you increase, then suddenly the factor of safety is drastically increased. Decreased. So the stability of the slope is reducing. Okay, and then after certain load up to B, so there is rapid change in reduction in stability. Then B to C, the rate of reduction is slightly reduced. After C, it is getting flattened. So that means after that it is going to equilibrium condition. And similarly, in the 20 degree, 30 degree, which can see this change. Like initially it is constant, then after sudden load, it drastically reduces the stability, and then after that it is reaches the equilibrium. Like, and after certain time, it is very not that rate of change is not significant. So now from this curve, what is important? This, if we identify this threshold load, we have given a name like this is threshold load. So this threshold load is very important for to identify the stability of the slope under building loads. So then this is basically all threshold load, and as I have mentioned, initially it is very linear kind, so there is no much change. Then suddenly plastic behavior, then again reduction is very small, then this constant. So this behavior is throughout for the slope angle, but with the cost of factor of safety. Like each slope has their initial stability and factor of safety, but after applying load, the threshold load is increases, but the trend is remain similar. So this is observation, like critical observation we have found from our analysis. Then if we really focused about other, because this is I have shown from slope angle, like this figure I have just illustrated, but this is of 20 degree slope angle, 20 degree. I try to just examine this. D is edge distance, like from the slope angle, slope face, how the foundation or building is distance is increasing, like 0. It is located 0 means this is edge distance. Okay, so this is the edge distance. So when it is 0 means building is located very exactly near to face of the slope. When this D is increasing, so it is going away from the face of the slope. Okay, so we have considered at the very near to the slope where we don't have any space, then we try to see 1 meter and then 3 meter. Then we have seen, like initially there is not that change of the stability is not that much, This is for slope angle 20 degree. But if you really going to apply some increase the load, then there is some change. Like if you see really that D is 3 meter, then that slope, that step factor of safety, if you it's going to higher if you keep the distance is high. As per IS BIS 1904, they strongly recommend like for different type of soil, it should be like 1 meter distance. But this is not like 1 meter or 1.5 meter. Rather, it is depending on the slope angle. If you change the slope angle 30 degree, then there is going to change. So this correlation is strictly depend on slope angle. But yes, if you should have sufficient edge distance to make your building safe in the hilly terrain. So after that, this is a same figure which I have already explained. So this is stability and loading intensity for static condition. Footing width, foundation width is 4 meter and edge distance is 1 meter. So keep these parameters neutralized form, and then we try to see the threshold load. And in every cases, as I have discussed, that threshold load is changing, the factor of safety is changing, but after that, it is going to form an equilibrium condition. Then if again we have applied one pseudostatic seismic coefficient to represent the earthquake loads, as we know that when you are introducing some earthquake force, definitely the stability or factor of safety is going to decrease. So as a result, even for the 10 degree of slope, we have seen the factor of safety is significantly reduced, even though 10 degree. And in each cases, if we compare two figure, you can see that the factor of safety is reducing. And in somewhat, like if you really compare the threshold load, this threshold load is also going to change due to influence of seismic coefficients. So further we increase the threshold, seismic coefficient to just see the effect of earthquake loading, intense earthquake loads, and we try to get all the trends and how threshold load is increasing, decreasing. So we can see like when we further increase the seismic coefficient, the factor of safety, the stability again reduced. So this is fine, absolutely, that following the similar trend, but the threshold load is also slightly changing, and in some cases for 10 degree, and then modified again further, moderately change in 20 degree, and we can see significant change in 30 degree or 40 degree. So these all have some influence on the stability of the existing slope under building loads. Okay. Now we have discussed like how threshold load, how the curve is coming from the in this elastic zone to plastic, like this elastic zone to this plastic zone, and then how it is going to reach the equilibrium. Does it have any relevance or relation with the failure mechanism? Yes, that also we have found. So 1997, Professor Paul from Department of Earthquake Engineering first time introduced like local problem and global problem. But after that, we again extended his concept in a different way, like to see the how failure mechanism takes place when the building's load or foundation loads coming onto the slopes. So before explaining to the old figure, let me take first figure, like when you have any slope consist of homogeneous soil and a single phase slope. So what is going to expected failure? I hope you all know that it is most likely to fail in a toe failure. Okay, so before that, in slope stability problem, you have different slip surface failure. Like when you have some very soft soil and the top layer, then slope can be failure through the face of the slope. So that type of slope we call face failure. Then sometimes when the slope failure through the toe, then we termed as toe failure. And in some cases, like this slope consists of totally loose material and debris and heavily susceptible to poor water pressure. And at that bottom, you have highly rigid layer. Then it may also with the base it can slide. So in that time we can call this base failure. So when you have some medium dense soil and homogeneous soil, so this is likely to be fail in a toe failure, like because your entry and exit point of the slip surface is passing through the toe. So this is typically a toe failure. So we assume this problem, then we started further increase the building loads. So this is factor of safety 1.91. This is then we try to see after increasing some loading intensity like 100 kPa, then factor of safety suddenly reduced, very small, insignificant you can say. But again the slip surface is quite toe failure. So in both the cases you can see there is no change in slip surface. So it is here we don't have any building loads. Here you have very small, you have building loads, but there is no change in slip surface. So this is like when a complete slope in getting influenced under gravitational load or whatever resistive load existing in the slopes. So we are saying it as a global failure mode. So there is no influence of localized building loads or something. But if you increase again the building loads like twice 200 kPa, then the factor of safety is slightly reduced, but you can see like there is influence of building load is coming into the picture. So now the slip surface is not same as the global failure mode. So there is the influence of mixed these buildings loads is coming into the picture. So now we can't say like this is a global failure mode because of the building loads is influence of the building load is coming into the picture. So that's why, okay, so now it is coming. Then in that case, again, if we increase slightly building loads, we can say the global slip surface is not existing right now. Okay. And again, if you increase like 500 kPa, see the slip surface is completely changed. Now it is surrounding the foundations. Okay. And if you further increases, that remains, localized. So this whole problem is getting converged to the global to very localized. Okay. But what we have seen in between global and local, two failure modes is coming. Like one is mixed failure mode. Why we are mixed failure mode? Because local, this if we say this is local kind of things and this is a global, so both are exist. But before going to the local, you can see this failure is reaching to the toe, but here it is not reaching to the toe. It's very surrounding the build foundations. So that's why we have given a name. This is mixed and this is pre-local before coming to the pre-local, pure local failure mode. And you will be surprised to know these failure mechanism is observed at the threshold load. And just after threshold load, you will be seeing this kind of problem. And then it is going to convert at this level. This is going to convert in a localized problem. Further, if you increase, this is like this region, you can see. So now you have like clear understanding when you have slopes and then how it is failing under building loads, stability can decrease. So this is very new kind of studies. So can we have in mind, like, can we give some guidelines or some correlation so that engineer can evaluate like the threshold load? Yes, we have considered some of the parameters like I have mentioned, footing width, edge distance, slope angle, seismic coefficients, and soil strength parameter, but all are in normalized form. Okay, after doing some several set of analysis or regression analysis, multiple regression, nonlinear regression analysis, then we try to propose one empirical correlation, which is quite satisfactory level, so that you can estimate the threshold load. Once you know the threshold load, then you should be worried about the stability of the buildings slopes. If it is the applied load is below the threshold load, then it should not be the concern about the stability concern of that existing slope. So this we proposed and we have published in 2023. Now I'll definitely discuss some of the studies in Japan. Like in 2021, Pacific Coast Tohoku earthquake, it is commonly famous as 2011 Tohoku earthquake, which causes devastating damages in coastal area as well as some of the other prefecture. As you know, like in India we call this district, but in Japan we call as prefecture. So we have like 48 prefecture. So in Miyagi prefecture, there is one town, new town, Yamamoto. So this is again a hilly site, and successive slope failures are there near the buildings. Okay. So then some of the researchers in 2012, they did stability analysis. But what they have not done, that they have not considered the building loads. But during my research, I was seeing that building loads have some impacts. But they just did slope stability analysis. They found that slope can be fail. But I was more interesting, eager to know that what is the role of these kind of buildings. See, how they have given one example, like these are the block. They have mentioned 1, 1, 1, 2, 2, 3, 4, 5. So this is a block 3. This block 3, and slope is digging through this direction. And actually, what they have seen like these multiple slope is getting collapsed. So, but this is a layered and filled material. So what I did, I try to first validate what they have done. Haido et al. In 2012, like under footing loads 0. So that means they have not considered the footing load. I am not considering the footing load. Okay. So just to compare their study and our study. So it is very, Haido et al., whatever they have done. So they are yield acceleration. What is yield acceleration? Like at what acceleration your factor of safety is become 1. Like the slope is at very rest, like just stable. Just stable means distribution, disturbing force and stabilizing force are equal. The factor of safety 1. So they have proposed like 0.42 to 0.46. They have done some trials, but what we have done, we are getting 0.45. So it's very, quite relevant. Then if we applied some loading intensity like building loads, then we can see the yield acceleration is going to decrease. When we have applied 50 kilonewton kPa per meter square, kPa, then we have, 50 kilonewton per meter square, then 0.38, then we have again twice, then thrice. Then we can see that 0.36, 0.34. So the yield acceleration is going to decrease. Then as well as failure mechanism, we have seen like if you have no building loads, then there is translational failure, which is a uniform slide of the whole mass. But if you introduce the building loads with a small intensity, then again it is going to same. But when you have increased 100, so this is a kilonewton per meter square, then we can see though the factor of safety not significantly changed, but you can see that the distribution of the mass moment or the failure of the slip surface is getting divided. Like now the influence of this load is coming to the picture. Then if you increase further, then you can see these soil mass, now it is become a problem of localized slope failure, not global. So we can clearly see like when you apply some building loads on the slopes, when it is reaching to the some amount, then it has own impact to make or cause the localized problem in the hilly terrains. Like what exactly you have seen in the photographs of the failure, it is mimicking the similar problem. Okay. So now after seeing all these analysis, so again we move back to that uh, failure, transition of failure. Okay. So this figure, localized slope failure occurs when high stress, concentration develop near the structural loads or slope discontinuities. So in a slope, we can see this is the active zone and this is zone 2 radial, because in slope it is mostly one-sided failure, and this is the formation of wedge, active wedge. It is not going to be the same as horizontal ground, because the reaction support from the soil mass, it is highly asymmetric, not the same as horizontal ground. So if I have already mentioned that in hilly sites, when we have visited many cities, we have seen the structure is very irregular. As a result, there is high probability to come the load as an eccentric load or inclined load. So we try to see what is the effect of eccentric and inclined loads. So there is only eccentricity is changing like 0.1, 0.2, 0.3. So this is a ratio of eccentricity and footing divided by footing width. So ratio. You can see like when eccentricity changing, that this at the 0.3, it is significant reduction of the reactions or soil mass participation. So we should also think, because of structural asymmetric, your soil mass reaction, which is indirectly relevant to the bearing capacity, is going to reduce. Again, the buildings may get very vulnerable. So this is a eccentricity is have influence on the flat ground, but it is more complex when you have sloping ground. Let us say I will again explain why it is more important. And is it like only eccentricity? Yes, when you have inclination of load angle, it is implemented at the slope exactly at the center, but with some angle. Then also the shape of the soil mass participation, or mass of the participation of soil, is going to change. And compared to eccentricity, that is going to significant, as we have considered like 5 degree, 10 degree, and 20 degree. So even for the 5 degree and 10 degree, we have seen compared to that, this is going to just some slipping kind of sliding can be occurred, because the moment of the soil mass participation is quietly different. And as a result, when we applied, we are constructing some buildings where eccentric and inclined both are there. So definitely there is significant reduction of soil mass participation. So it is the most, critical condition. So then I try to uh, quantify these, how area in terms of area ratio of shear zone. So how this eccentricity load and in loading inclination is increasing, and with respect to that, how the reduction or the area ratio zone is going to decrease. So which will be helping indirectly to give a rough idea, like if you are giving some inclination ratio and eccentricity ratio, that how much reduction you can expect. Okay. So different truths of the slope angle I have presented here, but you can, some of my publication you can find for the all slope angle. So these all will give you a better idea to know how the soil mass participation is interacting with the uh, building loads typically located at the slope face. Now, so far we have discussed about the mass participation, slope failure. Okay, let's talk about the structural aspects also. Like we know that when you are applying some of the load, that displacement or some pressure beneath the structures, as it is a in contact with the soil mass, so going to influence. If I'm talk purely, if you're applying some horizontal ground, even no eccentricity load, then it is likely to be going to uniform, right? But as this is a foundation which is situated on the slope angle 20°, so it will never going to be uniform. That is expected. But you can see this distribution is at the crust side, not is the crust, but crust side, and this is a very near to slope side. Okay. So at the very near to slope side, you have soil reaction. Sorry, the displacement, this is a displacement contour. So your displacement will be high because you have less soil mass participation. And this side you have, because you can see this figure all, you have influence zones here quite higher. So then displacement at this side will be quite low and toe side will be quite high. But if you again increase the eccentricity, there is a tendency that the structure displacement will be very high this side and a slightly uplift kind of phenomena occur at this side. Okay, because you have this is a slope side. So if you increase the further this side will be always critical. If you increase the eccentricity this side, this is going to be positive, but not this side. Okay, but we always, it is desirable that your load should be the centric one. Now these phenomena is increasing when you are increasing the eccentricity. Okay, then when you are increasing again the load angle of inclination, like slope angle, this phenomena is further going to increase. So as your slope angle is going to more steeper, this phenomena is going to be more prominent, right? Now these also suggest, like when you have sloping ground and horizontal ground, what we apply, like we apply Tarjagi's theory to encounter the bearing capacity for under eccentric load. But these eccentric effective width rule may not be applied in the case of sloping ground, because we have seen at even 20° or 10°, as here it is presented the 10°, the distribution of the pressure, or in terms of displacement I have presented here, vertical displacement, it is not uniform. So what we did, we considered the direct bearing capacity factor under different eccentricity, and we proposed a chart which can be helpful for engineers to use in their field. So they don't need to care about effective width rule, because if they want to apply this rule, this is not valid. So one of our paper, we have completely solved some of the example, and we have demonstrated like how this is not valid in case of sloping ground. Now, so far I have discussed about the numerical model and numerical analysis. We also did some physical model test in the Department of Earthquake Engineering, IIT Roorkee, during my PhD. And there, what I did, I constructed with the local vendor. We just created this tank. One is transparent, and we placed at the top actuator, electric actuator with a very constant loading rate applied at the top, and we applied some advanced digital image correlation techniques to see that whatever numerical results is giving, the failure mechanism and everything, is it going to be the same? So that was our motivation. That's why we have applied strip footing, so that the problem became two-dimensional plane strain condition, and we can obtain some of the useful information from the failure mechanism also. So we did some different relative density like 30°, 50°, and 80°. And then we try to see what is the mechanism and how the load settlement curve, because we have placed LVDT and this is an actuator. So we measured the load from the actuator using load cell, and the LVDT, which is typically for settlement. So basically we can get the load settlement too, and the failure mechanism in details to understand the physics from the experimental model test. And this is a schematic view how we have performed image correlation technique. Like we have spotlight and a high advanced camera with the specification, like what would the focal length, what would be the you know, ratio, aspect ratio, everything we have followed from the other uh, papers and past studies. Then we just try to color the local sand to make it capable enough to detect the strain or displacement or velocity from the images. So this is the image from the, I'm not going to discuss about the load settlement curve because uh, that is very, conventional, and you all know that it is obviously going to reduce when your slope angle is going to increase. Rather, I will focus some of the failure mechanism. Like if you see, like we all know Tarjagi's, Meyerhoff's conventional theories, like very early, they are their great contribution. Even they don't perform digital image correlation and others, but their great efforts to make development of basic understanding of the wedge failure and failure mechanism on the flat ground, like horizontal ground surface. So first, I try to see what we can obtain from the flat ground. Then I will see what is going on the inside of the sloping ground. So you can see like this is relative density 30% and footing width 500 mm. And we have increased the footing width, sorry, relative density. So this is, we have seen this a kind of punching. You say this is not much change, but just below it is just going to punching kind of value. So this is relative density very small, sorry, very loose condition, kind of not looser side, loose condition side. So it is expected to get the punching shear failure. So see, this all bulge active and real is going to punching kind of failure. But here, if you really look at the active zone is here, and then some radial deformation. Okay, even if you increase the footing width, the influence zone is going to increase again. See, this is very small, then it is increased active, radial, and again if you increase, keeping the all relative density same, like 80% and 80%, 80%. See exactly the value also and the size of the vessel wedges, period wedges. See, this is restricted up to this portion, but here it is changed. Okay, so the footing width had definitely some influence. We know what, and we are getting the similar trend from the horizontal ground surface from the digital image correlation. So it is well justified. Like again, we see this increase. So it is following the similar trend what was proposed by the conventional theories by Meyerhoff, Tarjagi's, Bishop's, eminent researcher in earlys. Then my contribution, like I want to see how these failure mechanism taking place while the ground is sloping. So there you can see this is a 10-degree slope when you are applying to the medium dense condition when loading. Then some slide like radial deformation are there and active, and this is actually not due to the loading, because when your soil mass is moving to one side, definitely a soil having tendency to fill that area. So that's why this is basically coming from the upside and going down. Okay, so this is basically one-sided with active wedge failure. Even if you increase the slope angle, you can see some, even though this is a pure kind of centric load, but these the initial stress condition, this should not be the same as horizontal ground. So when you are applying some of the load, so mass of the soil is having some tendency for sliding, because one-sided mass movement is there, and another side is going to fill up that uh, high stress concentration. So this is kind of some sliding, and then active deformation is taking places. So this is one-sided failure mechanism completely. And further, if you increase the slope, then again it is a one-sided slope failure. But the important thing, some sliding tendency is also observed from the experiment, and especially digital image correlation. Okay. So this is a critical observation what we have observed. First, this is kind of problem which is one-sided problem, and sliding may take places, even though it is a very, you know, vertical load applied in the top of in the footing or foundation. So then both or what I was discussing, like after observing all these things, now we are coming to some, social contribution from our point of view. Then we just done validate our numerical and experimental. Then we develop some of the charts which can be used in the ready-made in the field. So this is like the charts what we have developed for different condition, different C5, 5 angle of internal friction, cohesion. Cohesion is not going to influence the bearing capacity. So we just proposed some of the charts. Then another things I'm going to discuss, like so far I have discussed some of the basics of pseudostatic or bearing capacity and failure mechanism. Now I'll a bit discuss about the during earthquakes. Okay, so there is one way to either you apply the real ground earthquake motion or some synthetic waves, which is typically representing the earthquakes wavelets. So in our study, we just considered some of the typical Chamoli earthquake, Uttarkasi and Northridge earthquake to see the damages. To see the effect of the earthquakes, and this is wavelet also, which is called Cheng's wavelet. We applied with a different central frequency, and this is a frequency, predominant frequency, which is varying for different earthquake ground motions. Now I have discussed so far stability concern, bearing capacity, but in hilly terrains, you have another things which you should think very carefully. Like when earthquake comes, the interaction of different topographic features, the waves is going to further amplified. Okay. Okay, I think I'm going very deeper. If you have any questions or like, is it okay? You are getting everything?
Yes, sir. You
Yes,
can
sir.
continue.
And like you need to ask something or any doubts, because now I'm jumping to some other aspects.
So there is actually one thing that I was wondering regarding your lab setup that you described in the previous slides. Was there any the groundwater conditions was considered?
Yeah, groundwater considered some of the particular cases, but I'm not, no, due to lack of time, I'm not considering that part. But yes, it was considered what is the effect of water table depth in the stability as well as bearing capacity.
Fine, fine, fine. Okay, sir. Please
Yeah.
continue.
So now, any other like how many attendees you have right now?
Uh, right now, there's 69 attendees.
69. Okay, okay. So anyone, if you are going to, we definitely we can go interact at the later stage, but
Yes,
please
sir.
let me know if you have any problems or any queries. Okay. So in China, Hati earthquake 2010, and in like I told, Noto earthquake 2024 and others, and no Northeast earthquake. Some of the researchers they noticed that in the ridged or hilly areas, the amplification is quite 8 times. The amplification, the recorded station at the hillside compared to the other side is 8 times, sometimes more. I'm not mentioning that how much, because I also think like there are some mismatch in the measurement, but fairly they have reported 8 times is normal. So just think, if it is getting 8 times higher amplification, then what is the influence of that earthquake intensity in the hilly areas? So that is called topographic amplification, which is another aspect, another problem in hilly cities, topographic amplification. So I have particularly defined a name because I am not doing the different topographic. I am considering the simplified slope. So that's why I have given seismic slope topographic amplification factor. So you in this area, very limited researcher they have studied and they have done simplified model. So first I tried to follow them, like one of the researcher Asamaki from MIT and some of the like Tripp et al. From Austin, Texas. So they did a great effort to identify the topographic amplification. So I first try to compare our model with their reported results. This is a normalized frequency, like slope height by wavelength of the frequency and S stuff. So throughout this talk, discussion, I will talk S stuff. Okay, this is seismic slope topographic amplification factor. So S stuff is, and this is the slope distance, like along the slope surface. So this is the toe side, and this is the crust side, and this is the slope face center. So obviously, when you have horizontal ground, there is no much change, topographic amplification factor. So this is a ratio of what we have seen in the flat ground for a sloping ground divided by flat ground, just to normalized. Okay. So at the very near to the toe and the crust center and the crust, near to the crust, we can see the amplification is there. And then again, it is going to decrease. These small changes due to height difference in the ground. So as the slope again increases, we can see 1.5, more than 1.5 times, more than 3 times, even though 3 times is quite high. So from the numerical, so far, whatever studies are there, from this study, we can see like 1.5 times, 2 times, up to 3 times, which is quite possible due to slope topographic amplification. Now, why it is happening? Like one slope is coming to the slopes, then slope waves is going to form a wave destructive interferences and constructive interferences. When it is going to destructive, so there is de-amplification and amplification is taking place. Okay, so when this amplification is very near to the crust is high. Okay. So one of my PhD students from India, he is doing further investigation on stuff with different frequencies and the wave transformation, like how is wave is transforming from one phase to another phase due to change of distance. Okay, so like this is a toe and toe side, and this is a face. So how it is going to change with the location, the waves. So then he just tried to capture the effect of low frequencies, high frequencies. So based on that, we tried to see that when you have low content frequency waves or excitations, that is not going to that much influence. Yes, topographic amplification will be there, but that is not that high. But when you have going to that topographic amplification with higher side of like even 1, 2. So this is 1, 2 is very common in earthquake, but 10, 6 is very high. But even for 2 hertz, you can see 4 hertz. So the very irregular pattern, like amplification, de-amplification along the slope surface may take places, and like amplification can be very high at the crust side. Okay, so now my understanding is like how that transformation is going to shift. Like, is it going to make some formation of waves from surface wave to some other type of forms that we are currently under investigation, how it is forming. Hopefully, we will be able to see under different earthquake ground motions. So we are also presenting for different type of soils to see the nonlinearity effects. Then I will just briefly highlight that the structural part now. Okay. So this is a in my numerical model, I have considered like one typical slope buildings, and these are the boundary conditions, like absorbing boundary condition, like Biscuit's dashboard spring, and then we applied earthquakes and buildings is situated at the slope. This is not to the scale, so that's why to show the structure very bigger form. Okay, and I have defined the what is S stuff. So in this case, I have considered these type of 2 buildings, like one is step back building and setback buildings. These are the configuration of the structures. Now, this is very important. Like, what type of structures is really located in the hilly terrain? Do you have any ideas? Like, uh, in the flat ground, tall structure, high rise, mid rise building, low rise building. But in hilly terrain, the thing are different. Like, this is a flat ground terrain, first building, which we often call a regular building. But in other middle figure, you can say for formation configuration, split foundation, like one part is above and another part is very below to that. So there might be a some slope, which is cutting slope or something, and building is constructed. You can see in the real ground. So this is called a split foundation in hillsides. And in some cases, like your slope is constant, okay, steep slope. So what can be done, like you have one building then cutting the slope and the below, so this is a when you're stepping back, so if you consider starting from here, stepping back at the below, okay, so this is a step back building. And then this is kind of step back building configuration, again step back setback. Why step back setback? Yes, it is stepping back towards the this side, again at the roof also it is kind of setback, so step back setback building. And here again we have regular setback building, because this, if we consider this is a regular building, but at the top you have some sloping ground, so that's why this is a regular step back building. So this is a common type of buildings which you can see in the hilly terrain. Okay, now what I did, I showed in the beginning slide that we consider the soil. Most of the researchers, they have done some of the studies like how buildings is influencing and all, they have ignored the soil. But when it is your slope, you can't ignore that soil. Basically, the flexibility of the soil is very important to represent the soil structure interaction. So this is often in soil structure interaction, we call soil structure interaction importance factor. Like this is a fixed based time period of the structures with the ratio of to the fixed base condition with the soil. So I have given a name like topographic soil structure interaction in this. So this is a slope angle, and how this behavior is going to change with different scenarios. Like this is a different width of the buildings, and this is a height of the buildings for medium dense soil condition. You can see like as slope angle is increasing, that the soil structure interaction factor is going to increase. So definitely even for medium dense, what we have considered the soil properties, and you have very low to medium rise building. First of all, because in hilly sites, they are making high rise building, but it is not allowed actually. G plus more than G plus 4 as per codal provisions. So this is, that means the soil structure factor, is very important in case of hill areas. Not if you have very loose condition or something. Even you have some sloping angle and you are constructing this building, so this is very important to consider the soil structure interaction factor before designing or any kind of structural intervention. So I try to see the other component response, like how shear force, bending moment, and axial force deformation is taking in the places when you consider really the soil. So we can see some of the member which are short column, long column, because this is a very irregular structure. You have to combine by short column, long column, and combination. So this is very important. Like when you have the shear forces short column, you can see this is we have very large shear forces, and as well as in the soils, considering both fixed based and soil structure, topographic soil structure interaction. So this is very important uh, to consider this factor. Okay, and so overall, what I want to represents, like if you don't consider the soil, then you are not going to likely to get the large amount of axial force, shear force, and bending moment. So you are going to underestimate these forces by considering the force only fixed base condition. Okay, so I think I have discussed everything very clearly, and some of the major outcomes I can say, like we have clearly seen how the static and seismic bearing stability going to influence the slope, and initially it is constant, but then the threshold load coming into the picture, after that rapidly decreasing, leading to instability of that slope. So threshold load and safety of the slope footings are governed by slope angle, seismic coefficient, soil properties, and those are more critical, while the edge distance providing sufficiently to make the slope very safe. Bearing capacity decreases with the slope angle, loading intensity. So that also we have discussed. So though I have here mentioned the embedded depth, but it was not presented high here. But what I discussed, that effective rule cannot be implemented. So I will recommend use our charts for the site engineers. And then the footing of the slope settlement, tilting and non-uniform contact pressure or stress beneath the footing, cross side, lower side, I have just presented. So those are also important points you can take, whether you are an engineer or a researcher or undergrads or students or grad students. So this can be further a scope to research for your research or sort of investigation. So DIC further giving finite element and limit analysis and others are giving better idea to the consistently capture footing response, failure wedges, and amplification pattern. Then yes, earthquake has roles, especially the increasing and the structural forces, bending moments, air force, axial capacities. The topographic soil structure interaction is very important, which and cannot be represented properly by fixed based assumption. And some case studies I have discussed, which are really shows the importance of building loads on the slopes. Apart of that, I'm currently doing some of the hazards and land susceptibility in Aizawl districts. Hopefully, we are doing some of the case studies. You can see some of the recent publications, and I will encourage some of the young minds to join this kind of research and to just do your by to know what is going on in the real world in the research if you are interested, and most of the references are taken from my publications. And though this is not, again, you can see it in LinkedIn and Facebook, this is a big problem in Italy. Okay, many residential buildings are under threats due to rainfalls and shallow slope failure. But this is a picture due to heavy rainfall that uh, near to the buildings, residential areas, the sudden slope failures are there. And now you can imagine that uh, what is the loss of the local residents. So with this, thank you. And this is my email ID and contact, and you can find all the details. And I'll be happy to reach if you have any queries. So thank you for your patience, and I hope you
Thank,
have all have enjoyed.
yes, sir. Thank you, sir, for your insightful discussion. So now I'm requesting all the participants, if you have any queries or any question, so you may either ask to sir or you can write it in the chat box. So in the chat box, there is a question, sir,
Okay.
given by Dr. Saptarshi Roy. One more question already been come.
Complexity changes the seismic. Okay. Yeah, Dr. Roy has rightly pointed out your studies isolate the footing slope system, but in real hill city, foundations have adjacent structures, retaining walls, and the utility of trenches and all interacting. So let me answer it very clearly by making some. Yes, in real life, they do uses retaining walls and other protective measures, but please do visit in the hill cities. You will see that those measurements are basically when you have some cut slope, because without giving some retaining wall, you can't make a structure. But when you have like uniform slope, they are not providing. So before making a complicated structure, you have to understand the basics, like how a single structure is interacting with the slope. Yes, if you give like mitigation measures, definitely the interaction or the problems become more stronger. But I have initially taken a problem like to just see the how it is interacting with the slope and structures. Yes, it is going to change the scenario, but before you have to start from a very basic fundamental and simplified problem, then you can increase. Yes, that this kind of no, mitigation measures will improve the performance of the structures. But what I was discussing, like structure and slope, how it is behaving, and in the field also I have seen some of the examples, like many of the residents, they are constructing this sort of structure. Even you can see like Sikkim and Darjeeling, you will able to see even you have very uniform type of slope gradient, they are not using any structural measure. But in that case, they know that they can't mitigate or they can't do the construct the buildings, where they just layman language they visualize, they provide the structural mitigation part. Okay. And yes, the seismic picture, and it is the detectable experimentally. Yes, you can do some symmetric experimental, like in next phase with IIT Roorkee. We are planning to do some kind of checking large scale model testing, so that how it is interacting. We can say, yeah, it is possible, but yeah, we have very limited types of studies, and we need to further focus in this area. Yeah. Then hello, I would like to have a piece of proposal on Matthew. I think, yeah, Dr. Matthew, I think, yeah, it will be fine. I don't have any problem. Yeah, this is my one of the key interest research topic. I'll happy to discuss if you have any plan to review a proposal or review. But please, before that, read all the papers very carefully, because some of the dedicated studies are already there. So thank you. Yeah, welcome. And then foundation safety in hilly cities is ultimately a land users planning and problems such as much as an engineering one. There does a geotechnical engineer's responsibility and the urban planners begin. Yeah. And who is the bridge in the capital of India? Recently, I was involved in a meeting of Niti Aayog and others. I was just, seeing all these things. So before, there are some guidelines are there, but now the role as a researcher, we have to come up some of the investigation. We have to see what kind of problems are there, what can be the solution, not in terms of, because some of the conceptual and fundamental problem will never give you a ready-made remedy, because you have to understand, we have considered this problem, we have seen this behavior, we have developed some fundamental relation, and what is the significance of that problem at real scenario. Then you have to come up with the several studies. Once you are that level of understanding, then like most likely I have one project which is not under NL era, landslide risk mitigation, under the initiative of Prime Minister Narendra Modi. So we are dealing this kind of problem to mitigate the slopes. They don't have any provision. So we are producing general awareness of the localites, like residents. So this could be the another remedies. We are giving training and walkthrough workshop and invited talk to the PWD engineers in the different state district of Assam. So maybe this could be, I will not say like who will be responsible, like engineer or architect. Rather, we are all responsible citizens. We should take some initiative. We should do whatever we can do instead of blaming some others. Whatever we can do, we have to do. Yeah.
Yes, sir.
I think.
If participants have any other questions, if anybody have any other questions.
Even you can turn on your video and we can interact. Even no issue. If you feel like to interact directly, then there is no issue.
Okay, sir. Okay, sir. I think there is no other questions. So, thank you, sir, for your insightful speech on very emerging topic. So, on behalf of the entire organizing team, as well as our Department of Civil Engineering, Health Institute Technology, I, Ajit Kumar Padia, Assistant Professor, truly honored to offer the vote of thanks. We are deeply grateful to Dr. Sukanto Das, scientist, Port and Airport Research Institute, National Institute of Maritime, Port and Aviation Technology, Japan, for taking the time to be the part of this 1 week FDP on technology integration in civil engineering pathways towards sustainable development, and for delivering such a comprehensive and engaging lecture. He has delivered an interesting discussion on building resilient hill cities from foundation safety to the lessons of Yoshimoto land subsidence. In his lecture, Dr. Das have elaborately discussed a lot of interesting things like critical aspects of earthquake engineering, seismic slope stability, foundation engineering, field monitoring of geotechnical structures, soil dynamics, disaster mitigations. We have shown the Yoshimoto incidents, how it occurs, and what the preventive measure may be taken. We have shown the FELA modeling of critical analysis of slope stability. We have discussed few case studies of failures in earthquake. What are the steps to be adopted to minimize the landslide disasters? We have shown in his lecture. How the bearing capacity is decreasing with increasing of slope angles, low eccentricity. Through research, he have shown in the lecture. We have shown the research output on seismic slopes topographic amplification factor that related to the soil dynamics. We have shown typical hill buildings that can generally used in hilly terrains. So thank you, sir, for your detailed discussion and very insightful lecture. I think our participants have enriched through your discussion. We also thankful to our participants for their consistent and enthusiastic presence across the session so far. Thank you, sir. Okay, our session one of the day 3 program is now formally concluded. Thank you all the participants. And dear participants, please note our next session will be started from 3 p.m. today. So join the session positively 5 minutes prior to the starting of the program. Thank you all.
Okay. Thank you, sir. Thank you.
Sir, you
Oh,
were
I think
muted, sir.
I'm really sorry. I was disconnected. Maybe my network was
Oh,
not.
okay, no, sir. No problem, sir.
It was my pleasure, and thank you to all. And it was really nice to see all of some of the few unknown faces also. And
Yes.
hopefully we can see some other places. Okay, all the best for your event. Yeah,
Yes,
thank
yes.
you. It was my pleasure.
Obviously, sir. Okay, thank you, sir. Thank you, sir, for your time, sir. Thank you.
Participants, for our second session today, we have the privilege of welcoming a distinguished industry practitioner, someone who brings real-world engineering experience to complement our academic discussions. We welcome Mr. Surojit Kumar Datta, founder and managing director of Datkan Consultant and Engineers Private Limited, headquartered in Kolkata, West Bengal. Mr. Datta established Dotcon with a vision to deliver high-quality engineering consultancy across a broad spectrum, including geotechnical investigation, soil testing, structural stability assessments, failure analysis, structural health assessments, electromechanical engineering, and statutory testing and certification. Under his leadership, DATCON has earned recognition as a competent authority for safety audits and testing across multiple Indian states, including West Bengal, Jharkhand, Odisha, Uttar Pradesh, Bihar, and Rajasthan, and is authorized by respective chief inspectors of factories and boilers. This is a rare and significant distinction that speaks to the organization's technical credibility and Mr. Datta's personal expertise. Today, he will be speaking on a subject of national importance, structural health monitoring, a requirement for sustainable growth of the nation to address how monitoring the health of our existing infrastructure is not just a technical necessity, but a prerequisite for sustainable development. We are delighted to have Mr. Dutt share his experience and perspectives with us this afternoon. I am inviting our co-host, Mr. Shobik Dash, to carry forward this session and inviting you all, please join me in extending a warm welcome to Mr. Surojit Kumar Datta.
Good afternoon. Thank you. Thank you for your introductions. Really, it is my privilege to be with you. I also have the privilege to visit your college, means All Institute of Technology twice. It's a nice college. And really, I'm privileged to, thankful to the HOD Civil and also Dr. Saptoshir and others. So, as in the introduction, it has been told, we are working in so many fields, but these days, structural stability as well as condition monitoring, health monitoring is becoming a very major field of study day by day. Now, actually, what happens in a nation or everywhere, change is the urgency or the demand of the society. Change is required. Initially, we used to keep our money in safe. Now, in bank or in a plastic mode. Now, in fewer days, in the age of AI, ML, people are not depositing money. They are talking about how much data we have. Accumulation of data determines how rich you are. So that change is there. But as you know, in a proverb we are talking about, the rolling stone gathers no more. So whatever phase we are passing by, that has to be sustainable. The sustainability of a particular phase in this particular change will give the nation a stable growth. In India, when India is emerging ahead, towards the becoming a third economy, a fourth economy in the world, so whatever structure it has, new structure is coming up, no problem. Whatever old structure, along with our heritage is there, so we have to preserve this, So as I just, when you are going through some factories, what you have seen, that we have some tall chimneys, say 100 meter, 120 meters chimneys are there. So if after the design period, if you want to dismantle it, the handling of debris, pollution, and production loss is huge. So if we can have the condition monitoring or structural health monitoring periodically, we can assess the condition of this. Accordingly, we have recommended the retrospective methodology. In different institutions in master degree, retrofitting is and methodology has been taught, and these days it is a very coming up. Suppose we have a structures. Now we are working with some institutions for the determination of RLI, residual life index. What is residual life index? Suppose we have a structures, we have determined the age of a structure as per design, it is 75 years. So after rough use or so many other use, we have seen the deterioration of the structures. So how much residual life is there, that we are up to till date we are determining by statistical method. But now AI can be applied. We are working on that. So fortunately, Dr. Saptarshi Rai is helping me. If we can do something to determine the residual life index of a structure. It may be RCC structure, it may be other structures. Now we are talking about the sustainability. So we are coming to the slide later on. Just let me introduce one thing. So when we are talking about sustainability, we are talking about the disaster. Any change, abrupt change is disastrous. Disaster may happen due to the natural calamities. Disaster may happen due to manual fault, or we can prevent this kind of disaster by continuous monitoring. So in numerous institutions, disaster management is being taught. Disaster management is being taught with a particular word, preparedness. After disaster happened, we can do so many things. But before that, if you are prepared for this particular disaster through some technique, the disaster will be less, loss of life will be less, so national loss will be less, so we can contribute to the growth of a nation. So that sustainability point of view, if we monitor continuously the health of a structure, that will give us the sustainability in a greater extent. Now I'm coming to the slide one by one. Actually, we have a notion that in many companies are doing structural stability through entities. Entity is a part. Entity is not all about structural stability. In structural stability, design verification is a very important part. So design verification of the existing structure. In a very old structure, there may not be having some drawing. Drawing is not available. In that case, what we can do, we have to do the as-built drawing. After that, we have to do the design verification. Then entity data can give us the that input. So entity is a widely spread in civil structure, RCC structure, as well as load bearing structure. We can conduct this. Though we are very much accustomed with the entity of RCC and steel structure. Now, so to restore the heritage building, load bearing building are also is to be tested. The brick strength and mortar strength are being tested through pendulum hammer and this thing. Now I'm coming this by one. Why entity? So I think most of the attendees are knowing this. This is an assessing the existing structure in absence of proper information. So this entity, suppose in these days, I'm not talking about political thing. In whatever once after the disaster of Ulduranga flyover, we got the opportunity to check so many bridges along with the Jadavpur University Civil Engineering Department. At that time, we found so many defects are there in so many flyover and bridges. What happened? We have given the recommendation. And what they have done, the patchwork and the coloring. blue and white coloring. So face up is good, aesthetic look are good, but internal problem is there. When we are going to purchase a new flat, we don't know what kind of material are being used, what kind of TMT bar are there. Most of the structure are being erected with this TMT bar, which is lying for a long time. They are being rusted. As you know, rust is nothing but an electrochemical reaction. Whenever any rust is there, that increases the probability of getting more and more rust, and that is creating a problem with the RCC structures. Quick assessment of the structure. In earlier days, what we can do, we can send the sample to the lab. In lab, so many methods are there. We can find out the strength and this. If we want to have the in situ strength, in situ condition, we can do this particular entity. Sorry. In some cases, it is also required to assess the concrete damage due to fire and other thing. In so many, what do you call, insurance cases are coming to us as a, surveyor or, chartered engineer. They are coming to assess the loss of the particular thing. Due to fire or due to other thing, so many damages are there. So, we can assess how much actually damage and the cause of damage we can also find out through this. Okay, next slide. Only, testing is not important. As we, sometimes we are going for, full body checkup as a human being. Only checkup is not sufficient. We have to go to the root of the problem and find out the methodology of its particular solution of repairing. To suggest the methodology to be followed and applicability of non-destructive testing. I'm telling you one thing, non-destructive testing is very good, but one thing is very important, for a particular test, particular zone, one particular test is not sufficient. Suppose most of the people are doing what? We are doing UPB and hammer. So what RCC is concerned, we are doing UPB hammer. UPB hammer are giving a set of results. These results are not sufficient to understand the whole structure. There are so many other tests are there that if you just to analyze the exact nature of the structure, what you have to do, we have to analyze entire data. A particular entity method cannot demonstrate a particular structure. Next. These days, precast is being used. Nitin Gadkari, minister, has told in whatever new roads and bridges are being constructed, 25% construction are to be made by precast. With day and day, precast will be more and more predominant. In China, it is there also, a new building or a total building is being constructed with precast one. In India also, we Datkan Consulting Engineers also, we are trying to have, we are already given some proposal to the KMC and other corporations. What they are doing, when they are trying to remove the unauthorized occupier of the footpath, unauthorized of the portion, what they are doing, they are trying to remove them and giving shelter to others. And the time taken to construct a particular thing, it is too high. At that time, both of places are being occupied. So our suggestion is, the one particular, we are bringing something new, Chutki mein ghar. When everything will be there, precast, we will be bringing that within 1 or 2 days, we can construct a single-story building or maybe 2-story building. This particular thing is predominant, but to set up this thing, what we have to do, before setting up, we have to understand the quality of the structure. That is to be done through entity. Now, suppose we have some wall or structure, this kind of methods, entity, is giving a full advantage. What advantage? The entire thing can be seen through like a mirror. Everything is visible, whatever they are inside. You know, due to gross negligence during construction, what happened? Sometimes instead of using 10 rod, so we are using the contractor may be using 8 rod. Just sometimes spacing is this much. They are increasing the spacing to reduce the cost, to increase their profit. So after the construction, we don't know what exactly, whether they have followed as per the design or not. Through entity, we can check whether they have followed it or not. How much strength is there? When you are going to purchase new flats, also you can also check this kind of thing. Okay. Rapid accumulation of data. I'm just already told this data is important. If you are interested to find out RLI, means residual life index, how much more and more years you can use this particular structure. So this data will be much more useful. Next, it is also very less expensive. Since it is non-damaging, it is less expensive. Only thing is that we have to carry the instrument to the particular spot where we have to carry out the test. What is disadvantage I already told? Only one particular or two particular tests may not be sufficient to assess the structure or integrity of the structure, quality of the structure. More than one test method may be required. Now here another thing, since it is in situ, environment condition is very, very important here. Say damp surface may give us different result than the dry surface. Undulating surface will give other result, different result. So environment, if the temperature is high, it also may give it wrong information. So we have to have some standard environmental condition. Some condition cannot be determined with a reasonable degree of accuracy without destructive testing. I think most of you are knowing that through some method like hammer, we call it rebound hammer, we are finding out the strength of the surface strength of the concrete. Suppose we are taking a reading of the surface through a wide range. The data are not uniform. This is not conclusive. What the data is coming up from this hammer, this is not conclusive. Sometimes it is a wide variation is there. So what do you have to do? Then we have to do some semi-destructive method like core cutting. We have to take a core and then you have to send it to the lab to have a crushing strength. Then we have to know the exact strength, composite strength. This kind of semi-destructive thing is sometimes not recommended, since it is going to weaken the structure. If it is really required, if the entity method is not giving clear picture, then only it is very important. Okay. Then next. As you have told, there are so many methods. I think you have know this thing: rebound hammer, ultrasonic pulse velocity, pull-out test, core cutting test, rebar locator test, half cell potential, carburation test. Along with this, we have so many chemical tests also there. Among these, I think few of you may not be knowing pull-out test. And during this, you may discuss, you can ask anything, okay? So should we actually, all of our from civil background, sir?
Yes, sir.
Yes, sir.
All are from civil background.
All are from civil background. So I think everybody is knowing this rebound hammer. I should know. I should not go in the
Hello.
details of that. So I think pull-out test is uncommon to many of you, isn't it?
Yes, sir. It is a very new topic for most of us. So,
Okay.
please continue, sir.
Okay, I'm continuing. Okay. So as I have told, rebound hammer. So I will discuss in detail. Rebound hammer giving the surface strength, only surface strength. while we are going to rebound, I'm discussing here itself, we have a different slide also. In rebound hammer, while we are going rebound hammer, few things we have to keep in mind very carefully. When you are placing the hammer and pressing it, it has to be perpendicular direction. It is, if the rebound is not perpendicular, it is very simple, in our childhood, most of us all are doing, we have a ball, we make it jump, and we just count 1, 2, 3, 4, 5. We just count on how many rebound are there. So if I ask you, among this audience, among the attendees, who can make more than 50 rebound with the ball? Is there anybody who can do more than 50 rebound with any rubber ball on a floor?
No, sir, it is impossible, I think.
50? Impossible. 20?
Yes,
with a ball, rubber ball, with the ball with which we used to play cricket. In our childhood days, we used to do 1, 2, 3, 4, 5. We just have a competition with in our
sir,
childhood days.
That is possible. That is possible.
10, 15, it is possible.
Possible, huh? But here, one thing we are missing. 50, why 50? 100 is also possible. I am telling 1 is also not possible, may not be possible. It depends on which surface you are doing. If I ask or request you to rebound or bounce a ball on a sandy surface, can you continue?
No.
Actually, the rebound number, how many bounce, how many rebound it is being done, it depends on the nature of the surface on which it gets impacted. In our earlier ages, in physics, we have understood E, the coefficient of restitution of a heart. E is equal to velocity of recede by velocity of approach. So in that concept, if the surface is not hard, it will not rebound. The number of rebound depends on the hardness of the surface. If more harder the surface, more will be the hardest number. From this rebound number, say we are getting 30 rebound hammer. We have some chart. We convert this chart into compressive strength. Particular rebound number means this compressive strength. So this is the particular principle in rebound hammer. Ultrasonic pulse velocity, it is very common one. I think in most of the colleges we have seen this. This particular two instruments are available in most of the colleges. In ultrasonic pulse velocity, it is based on ultrasound. This is also applicable in steel structure. In steel structure, we use single probe. In concrete structure, we use double probe. What is probe? In probe, we have a piezometric crystal. When electricity is passed, EMF is given, this piezometric crystal is being vibrated. This vibration, the frequency of vibration matches with the frequency of the sound. Okay, that's why we use piezometric crystal within this probe. Sometimes this probe is called scanner, maybe transducer. So many names are there. It may be called probe, transducer, or scanner. What is the principle of this? We are sending some electric current. That electric current is being converted into sound energy. That sound energy, keeps the crystal, in vibration. This vibration has got frequency more than 20,000 hertz. As you know, we have run E is equal to energy equal to h nu. H is the Planck constant. So more the frequency, energy will be higher. That more energy is being allowed to go through this.
Sir, some disturbances are happening from your end. The audio is getting disturbed, sir.
Okay. I'm
We are
trying
not
to.
able to hear properly.
Okay. So just trying to. Is it okay now?
Yeah, this time it is okay.
Okay. What we are doing, we are producing a higher frequency sound. Frequency is nu. So we learned energy is equal to H into frequency nu. H is Planck constant. Higher the frequency, higher the energy. Our intention, so if we put the, originator of frequency, that is probe, on the particular surface, which is under test, that energy, sound energy, is allowed to enter. As you know, when wave is on a particular surface, three things occurs. One, reflection, one, refraction, another is attenuation or absorption. Absorption is called attenuation. Both things are same. But our purpose is to minimize the reflection. We want more and more energy, more and more sounds should enter the object. If it is reflected back, it is lost. Our intention is to peep into the structure. We have to look into the structure. So more and more energy, more and more sound energy should enter into the object. For that, we have to understand acoustic impedance. One particular word is there, acoustic impedance. What is that? Acoustic impedance is equal to, density into, refractory index. So we have there are two particular medium. One is the medium of probe, other is medium of object. When these two objects are different, their acoustic impedance is different. So what will happen? If the difference is more, it will create more and more reflection. Our intention is to decrease the degree of reflection. We want more and more refraction. We want more and more sound should enter. That's why we use some couplant. Some grease or a couplant are used that will reduce the air and it will match the acoustic impedance. That will allow more and more sound to enter into the object. So now sound has entered into the particular object. If the object, goes through the entire, length, and it's coming up, once again it finds two particular media when it's coming out of the object, one, the particular object and the air. So once again, a part will be reflected, part will be refracted. Now you want reflection. A part of reflection reflected back. When reflected back, we just take another probe to take the response of the reflected sound. Now we measure the exact time, how much microsecond it takes to travel the distance. Suppose S is the distance of the particular length of the path of the sound. S plus S, coming S, going S, 2S is equal to V into T. We know the velocity of the sound. We know that time. We have already measured microsecond. From that, we know S. So if the 2S we know, V we know, T, if the equation is matching, then it is okay. If we can see whatever S we have measured, whatever T is measured, velocity is not matching. Means before traveling the entire path, it comes back. Suppose it is a 5 meter, block, or say X meter block. Half mark, there is a gap, crack. That crack is not allowing the sound to penetrate. Sound is coming back from that. So time will be less. If time will be less, that particular equation doesn't hold good. From this equation, S can be determined where exactly crack is there. So if we not only detect the crack, it also detect the presence of crack and its location. Through proper scanning also, we can also find out the length. Now, some advanced machine are there. We can also find out the exact length of the crack. Through our existing, ultrasonic pulse velocity machine, we can also measure, but exact measurement can be done through some precise machine. That is ultrasonic pulse velocity. Now, I have told already, rebound hammer value are not uniform. Say, in a particular side of the wall,
Sir,
if
I think the PPT is stuck. We are in the NDT methods space only.
yes, I'm just moving one by one.
Okay, okay,
Next,
okay.
no, next. No. In rebound hammer, I already told. So while we are doing a rebound hammer, the surface should be uniform. If surface is not uniform, what will happen? The refracted or reflected sound will go in the abrupt direction. That's why before rebound hammer, we have to make sure the surface will be smooth enough. The surface is not damped. Okay, this kind of what we call precaution you have to take. Next. I've already explained the working principle of this, so I'm moving ahead. This is the apparatus all of you have seen, I think. Next. So already we need smoothness of test samples, age of the test specimen, moisture condition, and type of core segregate. You know, if some sort of pebbles are there, one particular case just now we have encountered, we have sent a team to JK Cement in Rajasthan. So my junior engineers are reported that, sir, no, our machine has gone wrong. Actually, we are not getting any response. And what happened? So it is not giving any reading. So in pulse velocity also not giving any result. Sometimes some kind of pebbles are there which is not giving the response to the sound. Next one. Here actually, if we have say this particular slide is not perfect one. This is good for a particular structure having strength 30 to 40. If it is M30 grade structure, we get 30 to 40 is good. If below, fair, accordingly we can judge. So as per IS, previously it is IS 11331, now it is 516. In 516 or there is no such good, very good. Will depend on the particular design strength. If it is more than design is good, or it is as per the design is good. If it is below that, it is bad. Okay. Sometimes what happens due to the corrosion of the structure, carbonation of the structure, the surface strength had been lost. So maybe core strength is good, but surface is not good. So at that time we will have to do other tests also. Next one. This is some example you have seen. Next one. Ultrasonic pulse velocity. I've told the principle. This is basically wave nature. Here we have to what we can understand integrity of the particular structure, homogeneity of the structure, to assess the quality of the structure, detection, presence, and approximate extent of crack. I have told how can I find out this. Next one. Already discussed this. This is all of us know. In UBB technique, since we are using here in concrete, we are using two probes. These may be direct, maybe indirect, maybe semi-direct. In many cases, direct reading may not be possible. What is direct? On the opposite side, at just the opposite side, two probes has to be fixed. We say length of the wire is 25 meter. It is not possible to have this. In that case, we have to have indirect. We have to place the particular probe, say 400 meter, 100 millimeter or 300 millimeter away. So we can discuss, we can measure accordingly. Next one. Now, actually, in UPV, we are measuring the velocity of sound through concrete. Whatever sound, whatever vibration we are sending, this particular vibration is going through concrete, and we are determining whether there is any crack in the concrete or not. As you know, the velocity of sound in steel is higher than the velocity of steel in concrete. So, if the presence of steel may also affect the result. So, accordingly, we have to be very cautious about the reading. That's why we have to scan properly. So, with a particular reading, we should not be satisfied. Moisture content of the concrete, as you know, with the moisture content, velocity of sound changes. Okay, as you know, in a Newtonian method, velocity is equal to root under k by rho. Rho means density. Density of the material, density of sound will vary with the moisture content of the atmosphere. Smoothness of the contact, since smoothness, help the sound to go inside the structure. If the surface is not smooth enough, all the sound are not getting chance to go through the subject. Next. This is as per IS 516. If the pass velocity is 4.5 kilometer per second, we call it excellent. 3.5 to 4. It is good. This is good, medium. This particular nomenclature is as per IS. So many of our client is raising their voice against the word doubtful. Why doubtful? Because NDT in a very particular spot may not give the true nature. That's why we have to have a random check. So below 3 is doubtful. The structure is not good. 3 to 3.5 medium. So you need some attention. 3.5, 4. Is good. If it is above 4.5, mean it is excellent. Any question here? Just this much is okay for you. I know. If any question is there.
No, sir, it is okay.
Okay. Next. Now, pull-out test, I'm telling you. As you know, you have heard of rebar. Before that, I have to tell rebar locator. Man. We are having rebar locator, sometimes we call cover meter. In cover meter rebar locator test, we see the depth of reinforcement under the concrete. Through rebar locator, we can locate the rebar as well as depth of the rebar. Their spacing also and their diameter. Theoretically, it is true. We can measure through rebar locator. It is not rebar locator. I'm telling you why I'm telling you rebar locator here. Through rebar locator, we can understand the presence of rebar. How much rebar is there? What is the spacing? What is the diameter? Since rebar locator, the principle is based on the magnetic lines of force. This is based on magnetic lines of force. When magnetic lines of force are superimposed on each other, say, due to suppose 2-3 layers are there, they are imposing on another. One lines of force is getting imposed on others. This particular result may not give us the true picture. That's why rebar locator, in most of the times, are not good predictive in nature. So this can give the idea of this cover, how much depth is there, this much is all right. So in the previous cases I have told you, in our rebound hammer, suppose we have to have an idea the strength of the surface. What you have found? The surface strength is normal, so no problem. Suppose surface strength is not uniform, it is not conclusive, then you have to have a core cutting. You have to take a core from the sample. You have to drill it. Before core cutting, we have go for rebar location. How much cover is there? As per IS, say if you're going for a 50 millimeter core, the length of the core should be 100, double of the dia. 50 dia, 100 length. So then, if the cover is more than 100, then only you can cut it. Otherwise, the drill will cut the river. It will be more dangerous. That's why before core cutting, we have to find out the cover depth. Accordingly, we have to choose how much diameter of core cutting is to be chosen. Suppose we have to do core cutting, but cover is very less. It is very predominant in case of silos, chimneys. In cement plants, silos are there. We are very accustomed. All the cement plants are our client. We are doing it in cement plant when we are getting ununiform rebar locator value. Sorry, ununiform value hammer value. They are asking to do the core cutting, but core cutting is not possible. But that will damage the rebar. Then pull-out test is there. What is that? We are drilling some portion. Suppose say small hole is being done by some drill. Then say 10 millimeter dia is being done, hole is being done. We take a rod of 10 millimeter with a particular chemical adhering to this particular steel rod. We just try to fix it in the hole. After giving a proper setting time, this particular rod is getting embedded with this particular structure. Then through a weight, we are trying to pull the that pierced iron rod. Whatever rod we have pierced it, we are trying to pull it out. We are going on increasing the pressure. We are going on increasing that pressure being monitored through a pressure gauge. The pressure at which the particular structure is broken, the pieces, the rod is getting out, that is being noticed, that is being monitored. Say X is the pull-out force. With that force, with that much force it can withstand. Before that, it is not. So we can that according to Newton's third law, every reaction has got equal opposite reaction. So at the status quo position, tension force must be equal to compression force. So X at X tensile force, it is coming out. Before that is okay. That means its compressive strength is X. So in case of very less cover structure, we use it pull-out test. Okay. Next one. Working principle I have already discussed. This is the particular machine. So sometimes pull-out test is called capo test, cut and pull-out test. Capo test, CAPO. Capo test. Actually, the cost of a capo instrument is too much. Only 5 to 6 machines are there in capo test here. So it is very costly. So this particular machine is being designed and manufactured by us. So instead of purchasing it with 6 lakhs, we just only spend 86,000 to manufacture or design it. So this is one wedge is there, 2 wedges are there. This is the rod through which we are pulling it out. This is the box. Okay. Next one. Core cutting test already I have discussed. So actual measurement of strength it is giving, density is also giving, and one particular thing we have to keep in mind before core cutting. With every core cutting, it is advisable to have a rebar locator test. Without rebar locator, core cutting is not advisable. It may damage the reinforced. Okay, next one. Next. This core cutting, huh? Already I've told about rebar locator. One particular instrument is called proboscopy. This is advanced version of rebar locator. Here we can find out more or less accurately the die of the TMT bar, die of the rod. Though spacing, and if it is not uniform, it is not judiciously done design, or then it may give wrong information, but somehow we can find it out. Next. I think most of us have seen the heritage building, which is more than 100 years, 200 years, 300 years. They are standing nicely. If it is painted well, it is maintained well, they are there with 200 years. But modern RCC building, they stand hardly 100 years, 60 years, after 60 years, 70 years, it is getting damaged. After that, it's so many expenditure, it may have led another 20, 30 years. But any structure without having some reinforcement may have a life of more than 200 years. You have seen, if you go to the old Calcutta para where we live, or court area, Calcutta court area, anything old house, you can see the building constructed in the British era, they are still standing. Because as the civil engineer, all of you know, steel or reinforcement are the main culprit of a structure. We are only using it to get, tensile strength, advantage of tensile strength, so that we can construct, high-story building. But if we have 2-3-story building without column structure, we can construct without TMT bar, it can long last. The TMT bar, what we are using, it gets rusted. How can it get rusted? The pores of the structure, water gets, moisture gets admitted. As you know, iron has got a very hygroscopic nature. It, attracts water, so it getting rusted. As rust, as a chemical, has got more volume than weight ratio. Volume per weight ratio is more than iron. So it expands. This expansion has no room but to have some push force to the RCC structure with which it is being enclosed. So with this push force, the RCC structure gets damaged and crack is being generated. Not only the structure gets have some crack, with the more and more rusting, the strength of the TMT bar is getting less. The purpose of the using a TMT bar for its strength. If strength is getting less, what is the purpose of it? That's why how much corrosion it gets. I think most of your house, wherever there is a bathroom or washroom, below that some the column gets crack, because the TMT bar inside this, they are more susceptible to have some corrosion. Next, how do you know that corrosion inside this? Will you open up all the structure to get the knowledge of how much corrosion the TMT bar has got? No. This particular structure method, Hubcell potential test, give us an idea how much corrosion the TMT bar inside the RCC has undergone. What is Hubcell? According to Nernst equation, E equal to E0 RT by ln, this kind of equation was there. So some oxidant, reductant, some sort of reaction are there. So one Hubcell is being generated through a copper sulfate solution, and the one particular portion exposed through this structure, one particular portion of the TMT bar. Through this, we try to find out the EMF developed in this particular Hubcell. That EMF, through this particular equation, Nernst equation, we can find out the EMF developed due to this. If the EMF is beyond minus 350 millivolt, we can conclude that rusting is more. If it is less than 200, minus 200 millivolt, it is okay. But if it is minus 500 means it is gone. We have seen in so many cases, more than 500 we are getting. So that thing, it is creating too much corrosion. That particular TMT bar dot has no strength. We have to replace it, or other method of retrofitting is to be suggested. Okay, next one. Any other question? This is I think you may ask some question in Hubcell 1. If you have any questions, sir.
No, sir.
Okay, thank you. Next. This is a working visual. You can see this. Next one. This apparatus I have seen. 2 Hubcell is being created. The test does not actual corrosion rate or whether corrosion activity has already started, but it indicates the probability of corrosion. Just to mind it, corrosion rate is very important. Sometimes one particular thing is get corroded over a period of time. Some portion gets corroded faster. So corrosion rate is very important, determining the life of a structure. There is some instrument with which we can understand the corrosion rate also. If the concrete surface has dried to extent that it is dielectric, the pre-wetting of the concrete is essential, especially for cement cell or other thing. This particular develop some local cell. As you know, local cell will be there to find out the EMF. Next one. I have told, if it is more than minus, it is as per IS, it is more than 350 minus, we call 95% probability is there to be corroded. If it is minus 200 to minus 350, it is more or less okay, or less probability. If it is less than minus 200, it is okay. Okay, 5% corrosion is admissible, no problem. So if it is minus 200, this particular, I am telling you, one particular misconception is there. Only Hubcell potential, suppose it is 50% corrosion, will you allow it? No, because we have to understand the age of the concrete. If it is a 50 years concrete, 50% corrosion is more or less acceptable. If it is 15 years, 50% corrosion is more. So time span is very important. How fast it is being corroded. If it go on being corroding with this rate, it will be not lasting as per design. Okay, right. Next one. This is the machine, Hubcell potential. This is the copper sulfate solution. So I am calculating the in millivolt meter through this EMF we are calculating. Next one. Now carbonation test. the depth, determine the depth of concrete affected due to attack of carbon dioxide. In atmosphere, there carbon dioxide there, hydrochloric acid is there. In the mortar, in the concrete, what are you using? Cement. Cement is basically, it is basic in nature. We are using limestone, CaO, CaSO3, from it is CaO is coming. So it is basic in nature. Carbon dioxide along with moisture is becoming carbonic acid, H2CO3. If this is coming in contact with the concrete, what will happen? This will trying to neutralize the basicity of the mortar or concrete. So the basicity of the lime is using as an adhering agent of the mortar. If the basicity is getting neutralized, the adhering capacity will be less. So I think most of us have seen in older building, sand is being, coming out. If you just rub it, some sand is coming out. What is happening? This sand, the mortar along with the sand has lost its basicity. It has no adhering capacity. So we have to understand, we have to calculate how much the depth of this particular damage due to the weathering effect. The carbonation, the rate of carbonation is varying from atmosphere to atmosphere. If it is a saline, coastal area, it is saline in nature. Hydrochloric acid is there also there instead of carbon dioxide. There also we get this kind of problem is there. So there, in that case, chloride infiltration is there. In that case also, mortar strength is getting decreased. Here, what we have to do? We have to use some indicator. Spraying phylloxera solution. If the change in color is there, or measuring, say we are drilling it. So two ways you can do it. By drilling, say 1 millimeter, then we spraying, phenolphthalein. Color is being okay. Color okay means it is getting acidic. Color change means it is in basic. If it is 2, so usually what will happen? We are taking some core and we are penetrating in different depth. Accordingly, we can understand how much depth is getting affected. And the carbonation, as you know, since the compressive strength depends on the, basicity of the adherence, or you call it, strength or the coagulation of the mortar. If they are getting loosened, the compressive strength will decrease. So carbonation affect directly to the compressive strength. Electrical resistivity, it damage and permeability to the concrete. If it is loosened, more and more, water or moisture are accessible to this particular concrete. So more and more damage will happen. So concrete or RCC or TMT bar will get chance to get more and more water, so moisture, so it will get damaged. So the carbonation is not only a test, it also give an idea of the damage to the concrete and susceptible damage to the TMT bar. If in a chemical plant where CO2 generation is more, concentration of CO2 is more, obviously carbonation will be more. Really, humidity also affect. Humidity, humidity, this oxygen, the water will attract CO2. That will create H2CO3. The carbonation rate will be more. Next. So this is, more or less common method in other, atmosphere. Say the atmosphere is having some chemical plant producing H2SO4, producing HCl. So penetration of sulfate and chloride, that is also important. what we will do? We take some sample to the lab. This particular sample is being tested for pH, chloride content, and sulfate content. This is a destructive test, not an NDT test. The particular sample is being taken to the lab. We just go on chemical test. Through chemical test, we can calculate the pH of the concrete. Then we calculate, the sulfide content and chloride content. Here, I'm telling one other particular test is there called RCPT. RCPT, rapid chloride penetration test. In chloride atmosphere, say in coastal area or in chloride plant, where chloride penetration has got more chance, then the rate of chloride penetration is being tested. How much chlorine is there is important, but more important is that how fast it is getting penetrating. So through RCPT, we have found another NDT test. This is not common here. Through RCPT test, we are calculating how fast chlorine is getting, penetrate to the surface. Accordingly, if it is more, we suggest some chloride inhibitor, paint. We are suggesting the structure to be painted through some paint chemical where, chlorine, aggression should be stopped. Here you can see to control sulfate, we can control this. Very simple, if you increase the, basicity of the surface, obviously the damage is there, but still the adherence will be there. Okay. Same thing to write. So up to this, we have discussed about, steel structure. When you're going to the industry, we can get, hybrid structure. Steel structure embedded with some RCC, pedestal is RCC, and the structure is in a steel structure. So now in steel structure, few NDT are being carried out, like, same UT test, ultrasonic thickness test, dye penetrant test. Few tests are there. Okay, one way I'm just telling you. Firstly, dye penetrant test. In any fabrication shop, when two things are getting welded, if there is a multi-run welding, what is multi-run? The thickness is more with this one filler metal, one particular run, this is not being filled up. So multiple run is there. So through the welding method, some slag is being there. So we are slagging up through hammering, and we don't know whether the welding is proper or not. Welding may have so many defects. It may have porosities, it may have slag intrusions, it may have less penetration, not penetration to the root. Till the root, it is not being introduced. So we have to understand whether the welding is good or not. What is happening? If you have multi-run welding, after getting full welding, if you go on testing, entire thing is getting lost. So what is suggested, during every run, or 2 to 3 run, one dye penetrant test is being done, whether there is any crack or not. This dye penetrant test is done for detecting the surface crack, only surface crack. The principle is very simple. It is the surface tension. In surface tension, we have understood one Jurin's law was there. If the diameter is very less, the penetration or water rise or depth will be more. H is equal to H is, inversely proportional to 1 by r square, like this. So suppose some, on welding surface, there is a small crack, which is not visible in a naked eye. What will do? So three particular chemicals are being used in dye penetrant test. First, we are spraying some cleaner. This cleaner, what they're doing? They are cleaning the dirt over this. There are so many micro cracks are there. If dirt is there, that dirt is filling up the micro crack superficially. That dirt is to be removed to open up the crack. First, clean up the surface through this chemical cleaner. After that, we are spraying some dye. If we spray some that dye is being there for some time. If there is small holes, this dye enters the holes. Understand? Enters the hole. Now, if we try to clean the very carefully, clean this particular dye, all the dye will be removed except those already entered in the hole. Now you are using some developer. That developer will identify where the dyes, red colored dyes already are there. That is being revealed. This will give an idea where some cracks, some porosities are there, surface defects are there, that can give us the idea of the thing. But if the crack is there well inside the surface, in subsurface, dye penetrant test is good enough to detect the crack. Understand? Only to detect the surface crack, dye penetration test is good. This is for steel structure. Now, as a civil engineer, I'm telling you, you are a civil engineer, so whether this is including a civil engineer, so as a civil engineer, we are going to check the structure. Structure has the two parts. One is steel, other is concrete. Both are to be checked. So this is also, you should have some idea, we should have some idea about this. This is dye penetrant test. This is 2 cans, 3 cans are there, cleaner, dye and developer. I've told you the method, through this you can understand. This is siphoning, action is there. So this is there, not applicable for porous material. If the material itself is porous, it's designed as porous, through this pores, dye will be there. It will give in a wrong understanding. So it will seem to be a defect. This is not defect. The pore was already are there. So for porous material, we are not recommending this particular test. You see, this is a boiler tube. In boiler, there is some conditioner tube are there. So many tubes are there. We are testing this kind of thing. As a boiler inspector, in every overhauling, we are checking it. In just few days earlier, in Vedant's plant in Chhattisgarh, some blasts were there. Few people were died. Now it is shut down. So why this happened? What happens? I'm showing you. This is a pipe. When the pipe at the point of bend, when point of bend on the outer surface, already due to bending, the surface is thinner. When pressurized, steam is going through, this is a huge pressure is being there on the surface of the thinner plate. If it is thin and becoming more thinner, it gets out. When the pressurized thing gets an opportunity to come out suddenly, some explosion may occur. That thing is very dangerous for this kind of boiler. In every power generating station like NTPC or high grade or anything in CSC, everywhere, this is being tested in every year through shutdown. every year there is a planned shutdown. All the corners, all the pipes are being tested. Whether there is leakage is there, some defect is being created due to continuous working. If there is there, we can change it. If it is not maintained, this kind of accident may happen. Understand? This is very dangerous. Okay. This is a magnetic particle test. The name itself suggests it is magnetic particle. So it is applicable only for the ferrous material. Ferrous, non-ferrous magnetic substance. Ferrous may be magnetic, maybe non-magnetic, you know. If it is steel is austenitic, it is non-magnetic. For magnetic material, we use it. This is once again based on magnetic lines of force. What is happening? We are spraying some iron particle through some kerosene or some medium. It is scattered on a surface. When through yoke some electricity being passed through the yoke, some what you call electric magnet is being generated. The lines of force is trying to pass through this particular object under test. And if there is any discontinuity, if there is any crack, the lines of force is forced to follow other path. From the path of the magnetic lines of force designed by the iron particle sprinkled on this particular surface, we can find out the presence of any subsurface crack inside the iron sample. This is only applicable for the ferrous substance, ferrous material. This is a yoke. Through this huge current is being passed. It is being converted into electromagnet. This electromagnet is being touched on the object on test, on which iron particle with kerosene is being sprinkled. The electromagnet produces lines of force. These lines of force passes to the object. This object, if there is a gap, these lines of force, trying to, get a other path, the, rerouting of this path will give an idea whether there is a gap, crack or not. I have already told, the name itself suggests this is only applicable for the ferromagnetic material. Already I've told, in any power sector or any other boiler, we are testing this. So to avoid any bursting of a pipe, thickness is being measured through ultrasound. Already in my first slide, I just try to make you understand how sound gives an idea of the thickness. Understand? So this is the principle through which we can measure the thickness of a wall of a pipe. In every pipe, when it is bent, the outer surface is already thinning due to more surface area. So due to this, it is getting thin. So if it is more thinning due to pressure, it is getting burst. Some holes are there. In steel, one particular thing is I'm telling you. If you just see the a tensile strength of a check of a TMT bar, you can check it before fracture or before crack. Some kind of notching is created. What is notching? Creation of a weak point. If you can remember the incident of our poster bridge collapse, some sort of incident, this kind of incident was there. First, the bolts, as the bolts used there, not used there, are getting first cracked. This was the incident which will tell us there is some problem. But they ignored it. That's why. So this kind of test is used to have a preventive maintenance, not the breakdown maintenance. For preventive maintenance, this particular test is very useful. This is apparatus. These days everything is digital, very small, thing. This is a probe. Through this probe, same what we have discussed in ultrasonic pulse field, same principle is there. Through this probe, sound is being entered. If it is allowed through the entire path, we can find out the total length. Now, in case of coated surface, difficult to perform the test. With usual machine, I'm telling you, so many manufacturers are there for Motsonic, Einstein, so many machines are there. But few manufacturers like Olympus and these things, they can also measure the thickness of the steel pipe having some coating itself. Without removing the coating, we can measure it. Now, another point I'm telling you, this is not in the particular slide. Now, if you want to check the thickness of the pipe, whether it is required to have shut down or close the machine. What happens when steam is being passed through it, the temperature of the particular pipe rises up to 480, 500 degrees centigrade. And these probe sound, whatever usual probe, cannot, function at this temperature. I have told you some couplant is to be used. At this temperature, whatever couplant we are using, they are getting volatilized. So, air gap is being created. So, this is not being used. So, special type of probe is being have been already there. So, some costly machines are there, Olympus and other thing. Also, few machines are there. We already purchased few machines are there. We are using it. At high temperature, without getting shut down, in regular use, we can also monitor. So what happens in sometimes where the pressure is more production is there, it's very difficult to keep shut down. So what we are doing, we have a continuous monitoring. Continuous monitoring, thickness is there without shut down. While the plant is in running condition, we can also measure through some special type of machine. So why I'm told you, so most of us know thickness gauging, thickness testing is being done at the room temperature. That is everywhere. I'm telling you one thing. On a fine morning, one day, one gentleman, he's a good friend in ITC. He was in ITC in a headquarters in Bhadrachalam band in south. Some sort of problem was there. From board meeting itself, he called me, Mr. Doctor, can you help me? Sir, I'm in a meeting. Is it possible to check the thickness at 500 degrees centigrade? So, till then, it was not, I never did it. So, I heard somewhere, I learned somewhere in a paper, it can be done. I'm telling it is more, I think 15 to 16 years back. At that time, this kind of probe was not there. So I told him, I have read it, so it is possible. So he was very, joyful. Then he asked us to do that. I couldn't find the probe. Then we brought the probe from Dubai. Then he did it. After that, it is now getting predominant everywhere. So everybody asking us, see, you have the machine, you do it. So at a running condition, we can do also check the thing without getting shut down. Okay. Now, portable hardness test. Why it is there? In hardness test, in lab, we have done it, Brinell hardness, Rockwell hardness, Vickers, so many hardness tests. In our lab, we have did it. But in situ case, in the side itself, why hardness is required? In every structure, it may be steel, maybe RCC, steel is being used for its robust strength. Due to corrosion or due to something else, due to high temperature, due to grain growth, or due to grain refinement or anything else, its strength is being lost. How to find out the strength? Strength means like your RCC, we are having compressive strength. In steel also, we have some UTS machine, mean ultimate tensile strength machine. We found out tensile, yield strength, as well as elongation, percent elongation. We calculate this three in this particular machine. But in a non-destructive way, how to do it? What we do, we take the hardness, portable hardness, means on the side, we take the impinge. It is just like rebound. We take the hardness at the spot. We convert this hardness into tensile one. There is a chart, there is a method. Through this calculation, from this particular hardness, we can find out the tensile strength of this particular thing. Just few days back, I think you have heard one particular iron steel tank in a Bardhaman station collapsed. Some accident occurred. After that, Eastern Railway ordered all the water tank in the station has to be checked. Its structure has to be checked. The structure is capable to withstand the load of the particular water tank. Now, what we are doing the strength, portable hardness test and thickness test to find out the residual strength, how much strength, how much tensile strength already it has. So whether it can withstand it or not, then we can do the design verification with this strength, whether it can withstand what is the volume of the water, we can calculate according to load, this load, whether it can withstand or not, we can calculate. So this is very important to have the strength, because in situ strength is not possible, measurement is not possible. This is the only method, only process, only way to find out this. It is metallography. So, due to so many things, temperature, phase is changing, metallography test is being done. If, stress concentration is there, if 3 to 4 members are there in a particular tier, some, dynamic load is there may be stress concentration, fatigue is there. So, to analyze whether a probable failure is there or not, we are checking this. Okay, this is totally metallurgical part. So before just closing, so I'm telling you, another method is there called GPR. You have heard this method, GPR. So this is a vast subject. Through this, we can have another way, we can talk on that. If you have anything, we are ending here. Please just try to interact. Thank you for giving me the opportunity. I am not so much habituated to have online one, but so it is a really great opportunity to be with you, to share my knowledge on this thing. Okay. Thank you, sir.
Thank you, sir. We are very pleased to have you. And that was a very vast presentation of yours and very interactive. So, sir, there is some question, if I may ask.
Please.
So, first question is, sir, corrosion test. If I am carrying it out on the roof, do I need to carry out chipping if the roof treatment is done? Also, does moisture on the surface affect the results?
First thing, you have to give water on the, if you are doing this carbonation test, hub cell, there has to be some moisture. Without this, you cannot create the hub cell. Okay, localized cell you have to create. So that is there. So this, you have asked whether roof treatment is being allowed or not. Okay. So these days, thermal imaging is being done. Before thermal imaging, this particular test was used to detect the presence of moisture in this roof or wall. This, okay, understand? This is also a method to find out water entrapped, water passage in the particular structure. This is thermal imaging is being very fast, and that's why thermal imaging method is being used to find out the water.
Okay, sir,
Seabed.
this is clear like this too. So the next question is, in a building, if there is damping issue, is there any NDT testing by which we can find out the exact source of water?
Yes, that is what thermal imaging. I've told you, through thermal imaging, we can detect the presence of water, also the source of water seepage.
Okay.
Okay. And I'm telling you, the rate of corrosion, where the rate of corrosion is, first we see the visual. I'm telling you, any inspection before testing, visual inspection is very important. Where the crack is more, the pattern of crack. Okay, the pattern of crack will tell you whether this crack is in the vicinity of the water body, vicinity of the what you call washroom. That will give an idea the source of there. In these days, conceal wearing is conceal water pipeline is there. This is very dangerous. This is very difficult to find out. So thermal imaging method is being used now. Thank you.
Okay.
Next one.
Okay. Sir, third question is, sometimes I have observed some disagreement in USPB and the rebound hammer test. Which one to trust?
Once again, I've told you that time, the rebound hammer is not at all, trustworthy unless it is uniform. If it is uniform, it may be not enough, but we are thinking it is good. So, core cutting is the only method, but core cutting is detrimental to the structure. That's why it is not recommended. So, what we are doing, try to calibrate the pressure. What is calibration? We are taking a core, and also we are doing some rebound hammer. If these two methods are matching, it is okay. So some sort of calibration is also always required. Okay.
Sir, there are one question again. How concrete strength can be predicted using only hammer or UPB or any curve utilizing both methods?
Strength. So, UPB is not giving strength. UPB is giving the, integrity, whether there is a crack or not. Hammer is giving the strength. Though there is some statistical regression curve, we can build up the data by the correlating the data of UPB and hammer, we can find out the regression curve. So through this, we can found it. Understand? So some statistical regression, regression equation is there. Through this, we can find out the correlation between, UPB and hammer. This will give an idea of the structure. But once again, this particular method depends on so many things: atmosphere, nature of the surface, and also temperature and
So I
environmental.
can follow some technical glitches there. Hello?
Pardon? Please, sir.
No, sir.
Please.
Sir, I think there is some technical glitch from Sovik sir's side. So
It is okay now. It is okay.
Is it? It is okay. Okay.
So should I repeat?
Don't. No, sir. It's okay.
No, sir.
I got your answer.
Okay.
In your end, it is okay. In your end, it is okay. We
Okay.
all can hear you.
Okay. Any question? Any more? Any other question?
No, sir. There are no, sir. Not a question.
Okay. Thank you.
No,
Thank
sir.
you.
Yes, sir. So thank you for the
Okay, sir.
wonderful
So-
session. Thank you, sir, for the wonderful. And we all
Thank
are
you for giving the
all are
opportunity.
enjoying.
Thank you, Raja sir. Thank you, Sapul sir. Thank you, others. AJD sir is also there. Thank you all for hearing me
Yes,
patiently.
sir.
Okay?
Agent is
Thank
also
you.
there.
Thank you. Thank you.
Okay. Sir, good afternoon to every person either present. Before concluding today's session, we really had an imaging and interactive question answer session. I'm Mr. Shobik Dai, Assistant Professor of Department of Civil Engineering, and it is my privilege to deliver the vote of thanks on behalf of the session. On behalf of our department, I extend my sincere gratitude to our esteemed speaker, Mr. Surajit Kumar Dotto of Dutton Consultant and Engineers Private Limited, for delivering such an insightful and enriching lecture on structural health monitoring, a requirement for sustainable growth of the nation. The session offered a valuable understanding of various NDT and chemical test techniques in RCC and steel structures and their practical importance in and evaluating structural conditions, identifying internal defects, assessing durability, and ensuring the long-term safety and serviceability of civil infrastructure. The discussion further highlighted the role of NDT and chemical tests in preventive maintenance and sustainable infrastructure management. Sir, your practical expertise, field experience, and detailed explanation have greatly enriched all the learners here and all the experience of the participants. And I would like to sincerely thank all the participants for their enthusiastic participation and thoughtful interaction during the session. My special appreciation goes to the organizing committee, faculty members, coordinators, and technical staff team for their dedicated effort for successfully conducting the FDP. Thank you, everyone, and sir, thanks to you for
Thank you.
elaborating and for the elaborating session. It is very enriching after all. Thank you, sir.
Thank you. Thank you.
Thank you.
Goodbye.
Thank you.